Here's another amazing, amazing question. Look at this. I want you to find me a value where if I did f of g of x and g of f of x, these two would give me the exact same result. In other words, I put a number here, let's say it's 50, and I put a number here, and let's say it's 50. This and this will equal each other. Oh, that's awesome. Okay, so how are we going to do this? Actually, it's really quite interesting and fascinating. Let's find this guy first. F of g of x. So I want f of, I'm going to put in my g of x right now, x squared plus 1. I'm going to put that in there. My f of x, of course, is blank plus 2. That's where the x squared, there's my g of x going into my f of x. Put that together, you got x squared plus 3, right? Okay, perfect. So there's this guy in red. Let's do this guy now in green. So now I want g of f of x. My f of x is x plus 2. Now, what's g? Well, g is x squared, so blank squared plus 1. Do the substitution. Pop it in there, x plus 1. Oh, sorry, x plus 2. Now, square this. X plus 2 squared is x plus 2 times x plus 2 plus 1. This guy works out to be x squared plus 4x plus 4 plus 1 to give you a total of x squared plus 4x plus 5. Right? With me? Okay. Perfect. So I've got this expression, I've got this expression, and look what happens. They have to equal each other. There is the clue right there. I knew there was going to be something coming up here. So let's take our two functions, these two, right? I'm going to do it right over here. X squared plus 3 that's this one, has to equal this one. So let them equal. X squared plus 4x plus 5. Now check this out. Like things on opposite sides of equal signs cancel, leaving me 3 equals to 4x plus 5, right? Solve it, bring the 5 over, subtract 5, subtract 5. I got minus 2 equals to 4x. Divide by 4, x equals to minus 2 over 4. Minus 1/2 or minus 0.5 for those people who like decimals. Okay. Now, how am I sure that this actually works? Well, use your calculator. Use the vars. Going back into here, I've got the two equations all ready to go. Look, I'm going to go to y3. You know that's f of x inside of g of x. And the other one is g of x inside of f of x. So let's just put them down. Here we go. Vars y1, bracket, vars y2, right? Bracket, okay? There's the first one. And the second one will be just the opposite of that. Second, vars y2, okay? Bracket, second vars y1, bracket. Those are the two equations. Now notice though how I took these guys and I don't want to see them because that's just going to clutter the diagram. So what does this mean? This is going to give you a diagram. This is going to give you a nice beautiful graph. Both of them are nice graphs. Now think about this for a half a second though. How do you know when they're equal? Think of Math 10C. How did you know when two graphs were equal? Because they met at a point. And you found that by using second calc and intersect. I wonder if that's going to work for us. We know what the answer is. We know the answer is 1/2. Let's see if we can actually figure that out. Ready? Graph it. There's the first one. There's the second one. Let's find out what this intersection point right there is. So second calc. Find me the intersect, which is 5, of the first one, which is the black curve, and the purple curve. Punch that together, and ready? Here's the answer. Oh, look at this. Oh my goodness, it's awesome. It's minus 1/2, exactly as what we predicted. What an amazing question.